Secondary 3 class. We are dealing with coterminal angles. This is part 3 of 9.1. So we were talking about coterminal angles. Now, what does co mean? And terminal, if we break up these two words into a prefix and then our root word here, co means joint, jointly combined, and terminal means the end of the angle. So what that says is I told you already that the angles, if I go right here to this angle, say I go to 100 degrees, right there, 100 degrees. If I'm at 100 degrees, remember that we can travel around and around and around and around an infinite amount of times. I would have that same terminal side if I traveled 100 degrees or if I went 360 plus 100 degrees for 460 degrees. Without this little rounded part here to show the angles that you traversed, you would see 100 degrees as the same as 460 degrees because they have the same terminal side for the angle. They have the same initial side too. It always starts at the x-axis here, of course, but if you travel 100 degrees or 360 plus 100 to 460 degrees, those have the same exact terminal end. And that is what we mean by coterminal angles. Coterminal angles have the same terminal side. Okay, same terminal side. So you notice that this right here, this side is the same with the 100 degree angle or the 460 degree angle, and there are an infinite amount of angles for which that is the case. What we're asked to do, let me show you really quickly too, I'll do it with red. If I move from here and I go negative and end up at that same terminal side, I have a negative angle. And what did I do to get to that angle right there? Well, I went 180 plus what to get 100 away from a full 360 degrees. And that's going to be 180 plus 70. It's going to be 260 degrees in the negative direction. And if I do that, then I also have another coterminal angle. So negative 260 degrees would be the negative coterminal angle. 460 degrees would be the positive coterminal angle, all for the same terminal side as 100 degrees has. So what we dealt with there are more revolutions. So we went a negative revolution, well, not a full revolution, but we went in the negative direction until we ended up at that terminal side, or we went in a positive direction all the way around for a full revolution and then back to that 100 degrees. So those two coterminal angles for 100 degrees, negative 260 and positive 460 in degrees, all are coterminal angles with each other. So if example 4 says give two coterminal angles for each given angle, one positive and one negative angle, then that would mean that we would travel the 65 degrees. I'm going to erase all this so we can see just a 65 degree angle. Okay, just a 65 degree angle. So if we travel 65 degrees, it's going to be about right there. That's 65 degrees. So what we would do is we would take 65 degrees and we would add one revolution, 360 degrees, to make 425 degrees. So if we went 360 plus 65, we would end up with a terminal side at 425 degrees also. So that's one of them. And then the other one is if I just travel in the negative direction around till I hit right there. And to find that one, we would take negative 360 degrees and add 65 to it. And when we do that, 360 minus 65, or negative 360 plus 65 is negative 295 degrees. All right, so those are the two angles that are coterminal to 65 degrees, one positive and one negative. Of course, we can continue to add 360 degrees and get more if we want. We could continue to subtract 360 degrees to get more negative coterminal angles, but we are only asked to find one of each. So we'll have 425 degrees and negative 295 degrees as our coterminal angles. All right, so basically we're adding 360, we're subtracting 360 from the angle we're given to come up with the two, one positive, one negative coterminal angle. So 540 degrees minus 360 is going to be 540 minus 360. It's going to be 180 degrees. Now, that ended up positive even though I subtracted 360. Why is that? And that is because we ended up with 540 degrees to start with. 540 degrees, where could I do this? Right here, is one full revolution, 360 plus another 180, and ends up being right there. And that's why, even though we subtracted 360, we ended up with a positive coterminal angle of 180 degrees, and that's because it's more, originally 540 degrees is more than one complete revolution. So instead of subtracting 360 from 540 and getting the same exact thing again, in order to get a negative coterminal angle, we're going to have to just continue to subtract until we get it negative. So 180 minus 360 is negative 180 degrees, and that is our negative coterminal angle to 540. So our answers are 180 degrees, negative 180 degrees. Those are our two coterminal angles, one positive, one negative. And again, this time we had to do something a little different than normal, and that is subtract 360 twice. All right, so the next two angles are in radians. So we have to, instead of adding and subtracting 360, remember that 2 pi is equal to 360 degrees. So we're going to add 2 pi and subtract 2 pi in order to come up with our coterminal angles. Now, these are, radians are parts of circles or fractions of circles, and therefore we have to deal with fractions, unfortunately. In order to add 2 pi as a fraction to 13 pi over 18, we have to have a common denominator of 18. So that means we have to multiply top and bottom by 18. 18 times 2 pi is 36 pi. So 2 pi is equivalent to 36 pi over 18, and when we do that, then we have a common denominator of 18 and we can add. So that makes 49 pi over 18. And that is one of our positive coterminal angles. So here we're going to multiply or subtract the same thing, multiply by 18, but we already did that above. So we're just going to replace 2 pi with its equivalent fraction of 36 pi over 18, and we're going to subtract them. So 13 minus 36 is negative 23 pi over 18. All right. Woo. All right, we're going to do the same thing. We're going to add 2 pi and subtract 2 pi in order to come up with our two coterminal angles. Now, I have to subtract and add 2 pi with an equivalent fraction out of 9. So we're going to multiply by 9 over 9, and we get 18 pi over 9, because that's what the equivalent fraction for 2 pi is in ninths. And that makes 14 plus 18 is 32 pi over 9. And 14 minus 18 is negative 4 pi over 9. All right, those are our two coterminal angles for the fractions or the radians of 14 pi over 9. All righty. Next up, we're going to deal with reference angles. So that's kind of taken up the space for us to be able to see reference angles. So reference angles are very important because pretty soon we're going to turn them into triangles, believe it or not. So what a reference angle, here we have our original angle, right? Angle theta, where we've started at our initial side and we've traveled a number of degrees until we come to our terminal side. So that's theta. Now, what happens over here is we have an angle right here that connects, if I just draw a straight line down, to the x-axis, and it creates a right triangle with the x-axis. So that can happen with every single quadrant. If I move over to an angle in this third quadrant, then that right there is my reference angle. Just like this right here is my reference angle. If I travel just in a negative direction to something in the fourth quadrant or an angle in the fourth quadrant, again, I would drop a 92, the x-axis, and that's going to be what they call the reference angle, or theta prime. Or if I just travel in the positive direction, theta is equal to the reference angle because it would drop directly down to the x-axis. So you have 4 different reference angles. I like to call them bow tie angles because you can see a bow tie there, right? And the angle is always tied to that x-axis for the bow tie angles. So reference angles I call bow tie angles because they always are one of these 4 quadrants, 4 angles that tie to the x-axis, and together, if you have one in each quadrant, you end up with the bow tie angles. All right, so what we would do is we would draw the 225 degrees, the angle in question, to find the reference angle. So 225 degrees is 180 plus 45 more degrees. That is 225 degrees. All right, then we need to figure out where this angle would tie, which way do we draw our bow tie in order to come up with a reference to the x-axis, and it is right there. So this angle right here is the one in question. Let me do that in a different color. So if this is the one in question right here, our reference angle, how much more than 180 degrees is that? Well, if we take 225 and subtract 180 degrees, you're going to end up with 45 degrees. And that is theta prime, or your reference angle. Always ties, because it's a bow tie, ties itself to the x-axis. All right, so again, we'll try negative 310. Well, negative means I move counterclockwise, and I move all the way to 270 plus another 40. So that's our 310 degrees. How do we tie it to the x-axis? Right there, right? That creates the 90 right to the x-axis, so it's one of the first quadrants parts of the bow tie. This right here is theta prime. How far is that from the x-axis? And right here is 2 pi, so we have to take 360 and subtract 310 to make 50 degrees. So our theta prime, our reference angle, is 50 degrees. Right, so that angle in there is the 50-degree angle. All right, the last one we've talked about in radians. We're going to break pi from here to here into 3 parts. So 1, 2, 3 parts to pi, and we want to traverse 2 of them, which is this part. So 2 pi over 3 is right there. So we've got it drawn. I'm going to write 2 pi over 3 so we know that right there is 2 pi over 3. We draw the reference angle back to the x-axis, and how far do we get to go in order to make it to pi? And that is 1 pi over 3. There's a pi over 3 left to get to the x-axis. And those are reference angles. So we went 1, 2, and then a pi over 3 to get to the x-axis, and that's why it's reference angles. All right, so this was part 2. I'm going to stop it, and we're going to move on to, oh wait, is this part 2? I think we're all the way to part 3, aren't we? Ooh. All right, we've got one more section for part 4, so we'll do part 4 next. Go ahead and click on the last part, part 4.